Today's lesson is going to be on Learning Target 4.4 that says I can determine the type of best fit function for a set of data. This data came from your review sheet. It's the first problem under Learning Target 4.4. And it says the table below gives the number of hours spent studying for a science exam and the final exam grade. The final exam grade is dependent on the time that you study. So your final exam grade is your dependent variable, which is y, and the time spent studying is your independent variable, which is x. So you can see the data here. So what we're going to do in this learning target is we are going to find the curve of best fit and the curve of least fit. And so what we're going to be looking at is this list of different types of regression, and I'm going to show you on the calculator here where they are. If you go to Stat and over to Calculate, you can see that here are the list of the best fit functions that I have listed on the paper here. So number 4 is linear, number 5 is quadratic, number 6 is cubic, number 7 is quartic. Your number 8 is a linear regression just like number 4, so we're going to skip that one. We're not going to do it twice. The next one, number 9, is logarithmic, the natural log. The next one, 0, is the exponential function, and the last one is a, the power function. Now when we do the line of, or the curve of best fit and the curve of least fit, what we're going to be doing is we're going to be looking at this r squared value. That's your coefficient of determination. And in order to be able to find that coefficient of determination, we're going to have to be sure our diagnostics are turned on. So we're going to do that now. We're going to go to second 0. That's the catalog, second 0. And this is on your peach colored sheet. Then we're going to go to the x to the negative 1 key right here, because if you look in this top corner you can see that the alpha key is turned on, and if you look above the x to the negative 1 you can see a little green D right there. So if I press this x to the negative 1, it takes me down to the D's in the catalog, and I can simply come down to turn on the diagnostics and hit enter twice, and my diagnostics are turned on. Now the next thing that I need to do is actually enter this data into list 1 and list 2. So I'm going to list the x's in list 1 and I'm going to list the y's in list 2. Okay, so we're going to go 2, enter, 5, enter, 1, enter, 0, enter, 4, enter, 2, enter, and 3, enter. And that gets me my x's in the list 1, and then we're going to do the same for the y's. 77, enter, 92, enter, 70, enter, 63, enter, 90, enter, 75, enter, and 84, enter. And then I always scroll back up through my list and I double check to make sure that what is on the paper is actually what is in my calculator, to make sure that I don't make a careless mistake. And 272. Okay, so we have the data in. So we do second quit to get back to the home screen. Now we're just going to simply go through and calculate the line of best fit, or the curve of best fit for each of these, and we're going to compare our r squared values. So linear is the first one. Okay, we just enter down through this list to calculate, and our r squared value here is 0.97807995588. And we write down the whole number so that we can compare. Now I'm going to go back to Stat, over to Calculate. This time I'm going to come down to number 5, enter through the list, and look for my r squared. So this is 0.9873049645. I'm going to go back to Stat, over to Calculate, come down to number 6, which is cubic, and enter through the list. And this one is 0.9946924144. Then we're going to do the quartic. So we're going to go back to Stat, over to Calculate, go down to quartic, enter through the list, notice that on this one right here there's a little arrow. You don't see the r squared. That little arrow tells you there's more data down here, so we're going to scroll down to get 0.996, 424, 0573. Okay, back to stat, over to calculate. We're going to skip number 8 and go down to number 9. Enter through the list. This one says error domain. So that means that this function will not fit this data at all. If you get that, you just write down error domain. And then you have to quit with your, go to number 1 and quit. And now we're going to go back to stat. We're going to go over to calculate. We're going to come down this time to the 0, exponential, enter through the list, r squared. Be sure you're getting the r squared and not the r. So that's 0.968015861. And one last time, this time down to the power function, which is letter A, and enter through the list. This one also has an error, and so we're just going to write down the error. If you get an error, that means that this one, the natural log and the power, are not even in the running, so we'll just cross them out. Now, what we're wanting to do next, and I'm going to move the calculator so we can work, have a little more work room here. We're looking for the curve of best fit. That is the r squared closest to 1. So this is 0.97, this is 0.98, this is 0.99, this is 0.99, this is 0.96. So I'm going to look at these two because those are closest to 1, 0.994 and 0.996. This one is closest to 1. So the quartic regression is the best fit. Okay, so there's the answer to question number 1. And now, or question A. Now question B, the curve of least fit. So we need to find the r squared that is farthest from 1. So 0.96, 0.99, 0.99, 0.98, and 0.97. 0.96 is farthest from 1. So the exponential r squared 0.968015861 is farthest from 1. So the exponential regression is the least fit. And there's the answer to letter B. Okay, I hope this has helped.